Hello everyone. In this video lectures, we are trying to learn what is the moment of inertia specifically for the area as well as the mass. And before this one, we need to find out here the few terminologies. We know that the moment means what is the meaning of that. And similarly, what is the inertia over here? As we know that the moment is nothing but, I'm going to be defining what is the moment. That's representing with the m, suppose. So that is equal to, we are going to be talking about the momentum of a force about a point is equal to the applied force and the distance, that is the perpendicular distance to the point of observation and to the line of action. Further, suppose I have taken this is going to be your object and the force is going to be acting over here, that is the external force is the F. And my observation point is going to be over here, A I am going to be say, the point of application that is going to be the B. The distance between these two, can you see the magnitude of the force into the perpendicular distance between the line of observation and to the line of action of that force, that I am going to be writing F into X. So then this I am going to be say the moment. It means that the body is trying to bend this object with respect to the point A. So then I'm going to be, what I'm going to do here? I'm going to be taking the moment of moment. Can you see here the terminology? I'm going to be say the moment of moment. The moment of moment is equal to, what is this one? I'm going to be taking the magnitude of the m, which we got it from the force into perpendicular distance. I'm going to be multiplying this m with respect to the perpendicular distance. So that I'm going to be taking m into x. Can you see the moment is nothing but the force into perpendicular distance, but here I am going to take moment of moment. The moment of moment means the moment I am going to be multiplying with the same perpendicular distance between the point of observation to the line of action. So then I am going to be substituting these terminologies, F into X into X. Then finally I am going to be getting Fx square, and this parameter or this quantity is going to be called moment of moment. Okay, so once we are going to be getting the moment of moment or the second moment, suppose we are going to be say. So once we are going to be getting, so that's I'm going to be taking here. So the moment of moment, MOM, moment of moment shortcut I'm writing, that's going to be F into X square. For the suppose I'm going to be taking, I'm replacing this force with respect to area of the plane figure or mass of the body. Suppose if I am going to be replacing the force with respect to A, so then what will happen? That's I am going to be getting A into X square, I will get it. Right? And similarly, I am replacing the F with respect to the mass. That's going to be M into X square. Can you see? When the force into the square of the perpendicular distance, we are going to be say the moment of moment. But if I am going to be replacing the force with respect to A, then what we are going to be calling, the terminologies we are going to call the moment of inertia of a plane area. The moment of inertia of a body, that I am going to be writing moment of inertia of plane figure or plane lamina, we are going to be calling. And this is going to be called moment of inertia, and this is going to be of a body, or we can say this is going to be the mass moment of inertia also. Mass moment of inertia, MOI, I am going to be mentioned here. I hope you are able to understand the difference between moment of moment, or sometimes we are going to be called angular momentum also here. And when I am replacing the force with respect to area, then we can say that is the area moment of inertia. When I am going to be replacing the force with respect to m of a body, then I can say that is going to be mx square, I will get it, that the magnitude, and that's going to be moment of inertia of a body or mass moment of inertia. So then what is the need to study this moment of inertia over here? As we know that, and we are able to understand what is the moment of moment we are able to understand. Now we will come to the point of inertia. What is the meaning of the inertia? The inertia is the inherent property of your body by virtue of which it's trying to resist the change of its position or its state from rest condition or maybe in the motion condition. So that means the inertia is trying to resist the change Suppose a body is going to be existed at one position, so then what will happen in this case? The body is going to be remaining at the position. That means its resistance to change its position. Suppose a body is in the motion condition, right? Then you stop, apply the external forces, but still the body is going to be continuously in the motion certain time. So then it is very clear that the body is not able to change its position. That means it is resisting the change. Then we can say that is going to be the inertia. And similarly, when I am going to be applying here the moment of inertia of a plane figure or area moment of inertia, we are going to be see. So, suppose if a body member is going to be subjecting to the certain forces, suppose a beam is going to be there, suppose this is the beam and it has its own cross section. Can you see? I have taken a square cross section, or we can take the circular cross section also. In this case, what will happen? That load is going to be acting over here. So then what will happen? Then in this case, this is going to be, we are going to be getting the bending forces. Can you see? When I am going to be supporting over here, so then what will happen? This force is going to be trying to bend this object in the downward direction. So then what will happen? This area will going to be opposing the bending of that member. So then this we are going to be calling, the area is going to be contributing to resist the change. What is the change here? It's trying to deform the body, but this area is going to be resisting the force. That means it's resisting the bending of this member. Then we can say that's going to be the moment of inertia of a plane figure, or we can say the area moment of inertia. Suppose what is the mass moment of inertia in this case? As we know that if you want to a body which is trying to resist the change in the angular direction, we can say that is going to be the mass moment of inertia. Suppose in this case what will happen? You have a wheel is going to be there. So in this case what will happen? The wheel is going to be trying to rotate about its own axis. At the same time it is trying to move in the forward direction, right? So then in this case what will happen? So in this case that is trying to resist the change of its motion. So then that quantity is going to be m into x square will going to be helpful to you, that how much amount of the torque is required to put the bodies in the rotational motion, or how much amount of the torque is required to keep the bodies in the rest condition. So then, and those kind of the parameters we are going to be calculating from this mass moment of inertia as well as the area moment of inertia. So in the further analysis, I am going to be taking the two objects which are having that means the circular shape. One, I have taken a solid object that's going to be in the cylindrical form, and similarly the second one I have taken same cylinder with hollow. So there we can see this is going to be the hollow object is going to be we have taken. So then what I am going to do? So in this case what will happen? This is the solid object and this is going to be the hollow object. We have the same length is going to be there. So then I am going to be taking the one inclined surface. So can you see this inclined surface I have taken, right? So then what I am going to do? I am going to be trying to keep on this surface. So in this case what will happen? So that object is going to be trying. So that I am going to be trying to keep that object on the inclined surface. So for the better visualization, I am going to be keeping in the line diagram over here. So can you see that is the inclined surface. I am going to be keeping this one in the longitudinal direction. See, can you see that's the longitudinal directions I am going to be keeping on this surface. So when the object is going to be, suppose this is going to be your inclined surface and this is the circular objects, I am going to be keeping a longitudinal direction. So there is a two objects we do have. So which one will reach the first? Can you see when it is going to be sliding on this surface? When it is going to be sliding on the surface along the longitudinal direction, which one will reach the first? That's the question we can say that it will take the same time for these two objects, right? For this solid as well as the hollow, it will take the same time to reach from the position 1 to the position 2, the ground position. If the same case I am going to be taking, that means I am taking the second case, I am going to be keeping in the that means in the diametrically I am going to be taking. I am not taking in the longitudinal direction. I am going to be trying to touch in this position. So that means suppose the same objects I have taken. Initially I kept like this. Now I am going to be keeping here. I am going to make to roll on the inclined surface. So then you can assume it here. That's going to be, it is going to be rolling. Okay, and here is going to be another roll is there. One is going to be the hollow, one is going to be the solid on the surface. So now you can tell me which one will reach the first. So obviously the solid one will reach the first and next followed by your hollow cylinder. So then when it is going to be sliding on the inclined surface, then both are reaching the same time. But when they are rolling on the inclined surface, the solid object is going to be reaching the first than the hollow cylinder. So the reason behind here is that this moment of inertia or the mass moment of inertia will going to be answer for that question. So how it is going to be answering here, that means we need to be understand how the mass is going to be distributing about its own axis. Already we told this is going to be your axis, x-axis as well as the y-axis, suppose we are going to be taking. When it is going to be rotating about its own axis, can you see the distribution of the mass from the centroid to the outer radial direction? And similarly for this also we can see from the center to the outer. So there we can see it is going to be completely solid object is going to be there, right? But in this case here is the hollow is there. So this is the material existed and at the center there is no mass is there. Suppose this is going to be in this direction. So can you see this is the hatching is going to be indicating your material, right? And at the center hollow is there. And suppose you are going to be taking the solid one, this is going to be completely solid. That means material is distributed. So then with respect to this point and how this area mass is going to be distributing, it will define which is going to be reaching the first. This the moment of inertia will help us for how much amount of the torque is required to keep the body is in the respective angular direction or angular acceleration, right? And similarly the area moment of inertia will going to be tells us and how much amount of the resistance is going to be developing from that area we are going to be calculating. I hope you are able to understand here how to develop the moment of inertia for the area as well as the mass. With these examples, I hope I am going to be reach you. If you feel any difficulty, please put in the comment section so that I can reach you out. Thank you.